Hello dear ones, let's start with trigonometric identities. Today we are going to simplify trigonometric expressions using some of these identities. So as an introduction, this is the last page of your packet, the notes packet, where you have all the formulas and identities and everything given as a list. So that's the formula sheet at the back, and we are only going to use part of it today in today's lesson, so which is this one. These are called Pythagorean identities because they are derived from the Pythagorean formula, so that's why they are called Pythagorean identities. The main one is this one, which is sine squared theta plus cos squared theta is equal to 1, and the rest two actually could be derived directly from here. So let's see how that happens. So you will understand it easily, and you will be able to, how should I say, assimilate it better, understand it better. So let's look at how this is going to work. So sine squared, my cursor was there, so it started writing there, sorry. So sine squared theta plus cosine squared theta is 1. So this is one of the identities. You can derive the other ones. If you remember this, the others are easy. So if I divide this by sine squared theta, the whole equation, not just the left side, but the whole thing. If I divide this equation by sine squared theta, so this will become 1. But you know that cosine divided by sine is a cotangent. So it will become cot squared theta, and 1 over sine theta is cosecant theta, and there is a square, so it is cosecant squared theta. So this was just the other identity we just saw in the list. If we use the same Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and this time I will divide it by cos squared theta, the whole equation, right? If I divide it by cos squared theta, then this will become 1, and sine over cosine is tan, so it will be tan squared theta plus 1 equals, and 1 over cosine is secant, and there is a square, so it becomes secant squared theta. So the other two can easily be derived from the original one, which is sine squared theta plus cosine squared theta is 1. So this is the most important one. And we'll be using this over and over in many situations. So for now, we'll only focus on this for today's lesson, this part, and these are known. You have been learning this a lot. The others we'll use later. But keep in mind that sine and tan are odd functions, and hence they're reciprocal functions also. So sine of negative theta is negative sine theta, and cosecant negative theta is negative cosecant theta, and so with tan and cot. But cosine is an even function, so and hence it's reciprocal. So cosine of a negative angle becomes a positive cosine of that angle. So now let's get started with the first page of the notes here. We are required to simplify trig expressions. We are simplifying, okay? So these are different strategies suggested. You would rewrite using reciprocal or quotient identities, if that is the case. There are several ways you can simplify, not just one. So once we know how to simplify, we can actually solve in the later lessons. So we also have to look for any Pythagorean identities that you can use in certain situation. Or maybe if there are like addition or subtraction situations, you may want to get a common denominator for them if you find a fraction, and or break fractions apart. You can use even factoring. So the bottom line is you have to simplify in a way that you will get a single trig function as your answer. Okay, this whole thing could be written out as a single trig expression. So let's get started. So Here we have in the first one secant theta minus sine theta times tan theta. So what we could do is actually bring them down as fractions. You know that secant is 1 over cosine. So you could write this as 1 minus cos theta. And sine theta, there is nothing. Its sine is by itself. But tan is sine over cosine, isn't it? So we have it. So we have two fractions with same denominator. So we can write it as a common denominator, cosine theta. And in the numerator, you'll have 1 minus sine theta times sine theta is sine squared theta. Okay. Normally, the square is written on the top of the word of the trig function, cos squared theta, instead of sine theta squared. That kind of situation. So 1 minus sine squared theta. But we know pretty well that sine squared plus cosine squared theta is 1. So if I actually subtract sine squared theta on both sides, what would happen? This is a side work, okay, scratch work. So this is cosine squared theta is actually 1 minus sine squared theta. So I can replace this numerator with cosine squared theta. So cos squared theta over cos theta, right? So that means one of them can easily be cancelled and your final answer is just cos theta, okay? So that's how you have to simplify. So normally all these expressions can be brought down as a single trig function. So let's look at this now. You can pause the video and try this all by yourself and then check your answer. So sine A plus cosine A times, now tan is sine over cosine, isn't it? So these will actually cancel and you'll be left with sine A plus sine A, which is 2 sine A. It is really simple. It's even simpler than the first problem, isn't it? So this is the answer. Okay, so let's move on. You can now pause. At any moment you can pause, my dears, and then you can do all by yourself. So there are actually several ways you can come to the same answer. In this particular question, I'll give you two ways, okay? We'll start out with what we started out with, like breaking this down to its trig ratios, cos square u over sine squared u minus 1 minus sine squared u. Since both the denominators are same, I can write it as sine squared u, and here this is cos squared u minus 1, which could also be written as negative of 1 minus cosine squared u, right? But we know pretty well from our good old sine squared u plus cos squared u is 1. If I subtract sine squared u on both sides, actually, so cos squared u is also 1 minus sine squared u, isn't it? Or maybe the opposite. Actually, I could use the other one. So you can write this as subtract the cos this time. So the sine squared u equals 1 minus cos squared u. So this becomes negative of sine squared u. So you just have to replace this with sine squared u, right? So you can cancel this off and this is negative 1, okay? Alternately, you can also do this with our other formula here. What was the other formula with cot square? We had 1 plus cot square theta is cosecant square theta. You can directly use that. You don't have to go through this longer route. You can actually write cot square theta as cosecant square theta minus 1. Okay, so that would be, so let me write the question once. Cot square u minus cosecant square u, and cot square u is actually 1 cosecant square u. Let me write it again, sorry. So it is cosecant squared u minus 1. And we have this already here, right? And this will cancel off and you can write the answer simply. See, this was just 2 steps, but here there are several steps. So we can catch ourselves sometimes by going through the long route. You're actually wasting your time. You might want to think about a simpler way. All this comes with practice. The more you practice, the more you get it into the heads, like to the understanding that we can do things alternatively in much more simpler fashion. Okay, so similarly, instead of writing each of them into sine over cosine and cosine over sine, it'll be a lot longer route. But if you actually see here, sine over cosine is actually tan, right? So you can actually write this as tan x times tan x plus cot x. And then distribute this over, right? And when you distribute this, you'll get tan square x plus tan x times cot x. Okay, see, these two are reciprocal functions. So actually you're multiplying with each other. This becomes 1. So this becomes tan squared x plus 1. How, Miss Madhavi? Please explain. See, this is sine squared x over cos squared x. Sorry, there is no square. Sin x over cos x, and cot x is cos x over sin x. Wouldn't they cancel off? So this becomes 1. And what is 1 plus tan square? It is secant square x. So that is the answer here. Okay. So you just have to think differently. So I'll do as many as I can in the 15-minute video that I can do. It's already 11 minutes. I have 4 minutes left. So I want you to try these two, and I want to go with much more complicated ones like the 9th and 10th. But the key has, my review packet will have a key, so you can see your answers and confirm. Okay. So in the seventh question, actually, let me do the 9th and 10th. Sorry, so here, this is a plus b times a minus b, that kind of situation, right? And what is a plus b times a minus b? It's a squared minus b squared, okay? So now this could be written as, because of that formula, cosecant squared x minus 1, because 1 squared is 1, isn't it? Divided by cosecant squared x. But what is cosecant squared x minus 1? So now you have to go to the formula in the beginning that we saw, right? 1 plus cot squared theta is cosecant squared theta. So remember that. So 1 plus cot squared theta is cosecant squared theta. Okay. So I'm writing that for you here. So when we have subtracted this 1 on both sides, we get cosecant square x minus 1 is actually cot square x. So this becomes cot square x over cosecant square x. Okay. Now we can expand these two and we'll see that cot square x is cos square x over sine square x. And cosecant square x, which is in the denominator, it is 1 over sine square x. It'll flip, and this comes to the numerator. So this will actually cancel off, and you'll get cos square x. That's the answer for this. Okay. So this is how you go about with these questions. I'll have the key online in Schoology, so you can access the answers for all of them. But I want you to try, because that's how you will learn how to work with each of them. All right. All right then, I'll see you next time. Thank you for watching. Bye-bye.